Hello. Right. Turn the music down a little bit. A little bit backgroundy. There we go. Sorry about that. Having some technical issues today. My webcam decided to stop working. Yeah, sorry about that. So a little bit later than expected. But hopefully that's it. Hopefully that's the last of the technical difficulties. So the first thing to do, I think, is to have a look at where we got to last week. There we go. This is our game so far. Plug in, and we can see in here got the man running around window. Sort of the bullets are sort of tracking. Not fantastic, but we are going to sort that out this week, and we're going to stop the. You actually can't see the. Can you see the mouse? Not sure if you can see the mouse on the stream, but it's escaping the window, and then we stop being able to move. So we're going to resolve all of those issues this week by converting the project to a Tauri project. So I think take the music down just a little bit more, and yeah, there we go. And yeah, so we're going to convert it to a Tauri project, which will let us capture the mouse basically and essentially recenter it every time, which is what most first-person shooters do. So you probably noticed that, like most first-person shooters, you load them up. If you have a dual screen setup like I do, you load up one screen and it captures the mouse, and you can't escape. But you have to actually minimize the game or do something else to allow the mouse to escape. And that's what we've set up today by turning the desktop app. So first thing we want to do. We've already got the Tauri installed, so we should just be able to do cargo Tauri init. And oh gosh, I haven't thought about this. It's currently called VC clone. Yeah, we'll do that. We'll call it that for now. And window title should be VC clone. Where the web assets, we'll call that dist, but that's okay. URL of the dev server is going to be localized 1880. And the front end command to run is going to be trunk serve. Front end build command is going to be trunk build. Okay, there we are. We have our app. And that's as simple as it is. So we'll just have a quick look at what that actually does. So it creates this source Tauri folder, and in here is the actual desktop app with a conf and everything here. So all of those details are just put in here. I think that needs to have HTTP in front of it, like that. And I think we'll play around with the size. Won't make it resizable because that will mess with everything. So we can always add that later. Yeah, so now we've got that, and I think the command to run now is slightly different. I'm going to call it cargo Tauri dev. Lost the other window. So just while this is building, it's just rebuilding the cargo part. Want to make some changes to the application as well. Just going to check out the source. So we've got main basically just calls the lib file and runs from there, and this is what does the actual building of that. There's only a couple of bits that we need to add into here. Guess we can start putting them together while it deals with all of that. So yes, we need to add the towel plugin first, because the okay. Oh yes, it's done some. Yep, it's done all of those. That's great. And I'll actually open up the window so we get that going. Source Tauri there. We're going to do cargo add towel. This is what actually lets us control the mouse. We have to add that special library. Obviously, that's added that there. Great. And at the top here, we want to do DPI and physical position. That. And then we just want to create a Tauri command. So Tauri is really cool. It lets you run essentially a window that hosts a web view, and then you can actually make system calls back to the application. Actually, it's finished compiling, so I can show you what it's got. So this, as you see, it's as promised. It has the desktop application with a window, and then inside we have the thing. Obviously, that's a little bit small for the game size that we chose, hence why we've got these overflow on there. But that should seem fairly familiar. That's what we had in the browser. So let's close that, and we'll go and tweak the Tauri conf. Actually, make that 1200, and that makes that 900. Just run again from here. I think without saving this, hopefully that should. They didn't save it in a bad light, and we'll just create a bad position, and we'll create this. So call this center cursor. Yes, we also need to. Is that? No, that's it. Yeah, it's just that. So center cursor. Window Tauri window. So that gives us a handle to our window. Oh my gosh. It's added a whole load of rubbish there. We're going to remove all of that in a second. So that and size equals window inner size. Oh, okay, interesting. It's given us a whole load of stuff. So so this is grabbing the inner size of the window, setting the physical position to size height, and yeah, that's actually correct. So great, that's all working as expected, which is brilliant. So let's do that, and then we just need to plug this in so that we can actually call that function. And do that by adding the invoke handler. It's kind of guessed what we wanted to do, and that is exactly it. So that should do that, and that won't actually do anything. So we see it's reloading now, which is great because we're running it in the Tauri dev mode, which causes it to reload whenever something changes in the project. Okay, we've got a better size here, and see it's still not capturing the mouse, so it's still sliding off the edge, which is fine because that's what we expected. We have to actually call this function to tell it to center the cursor. So we do that inside the sorry, I'm just checking. I cheated slightly and I ran a test on this. So even though I am technically writing all of the code on stream, I did actually run a test to make sure this worked because it's one of the more complicated parts of this. So the first thing we want to do is going to be inside the game project, and it's going to be on mouse move, which is when we're handling the mouse move. So that's that, and yeah, we want to change the last. Yeah, we need to get the. Okay, that's kind of predictable what we want to do, and the y diff equals 1 minus last y. And then instead of storing this, we actually want to get game width as 2, and game height everything. So this is setting it back to the middle, so everything is going to be relative to the middle. And then yeah, okay. Let me actually pass the. Yeah, we need to tell the player character where to look as well, but we'll do that in seconds. Oh, it's there. Oh, but this isn't the wrong one, that's why. So I will take a copy of that and then just undo everything, so that's the mouse down event. Okay, yeah, we're back to where we were, and we replace those with that. Okay, and now let's look. So, and now we're just passing the difference to the player, which is what we wanted, which is great. So, yes, in the on mouse move event, before we dispatch it internally, we're going to call the wasn't binding futures, bind gen futures, spawn local, and we want to call a new function that we're going to make, which is that create utils center cursor Tauri, and that doesn't take any arguments, but we do need to now create that function. Inside utils. We'll create that at the top because I think we're going to end up getting rid of a lot of these dummy functions that we've labeled with this to get rid of the warnings, but so this will be hub async function, and returns a result string, and we want to replace all of this with just a simple invoke. So we're invoking our function by name, because that's what we that's how we do it. And we're going to need to add the imports for JS value. Just going to copy and paste them. JS class, we just need JS value. That's the only thing that we're using here. Cool, and it's now saying we don't have an invoke function, which is as expected. Good question. Do we have wasm binding futures? We do. So we do have a version of that. And I've realized where I used game width and height, that won't work because what have I done? I've done nothing. This needs to be different. So yeah, because this isn't the value we want isn't going to be it's going to be read from the Tauri conf, the game width is the current window size, so that's which we set to 1200 900 in the Tauri conf, not the game width and height, so they're not actually constants that we can call. And now in the main, we want this main here, the one for the project, and we want to up here add in the wasm binding preludes, and then just above the main function, we put in here wasm binding, and this is going to be unsafe stern C, and I'm just going to copy and paste this because it's not, but we'll have a look at it. Inside the namespace for the Tauri internals, and we're going to be invoking, we're going to be calling the invoke function, which allows us to invoke the functions by name and by string, their name, and it does all of the glue. It sticks that together for us, which is great. So that now compiles. So the thing I need to do is bring this window over so you can see, and as you can see, it's recentering. We can also hide the cursor, but I've left it in for now, just so we can see that it is actually doing that. And you can see that we can go up as much as we want, we can go down as much as we want, left and right, and never escape the window. If I want to escape the window, I can just right-click, call up the context menu, and then the cursor can escape the window. But as soon as it re-enters, it snaps back to the middle. Yes, I also noticed last week, I think, that we can see the green, which is the background default color, and that's that one should that needs fixing, because basically the sky runs out. So the night sky that we created here runs out. So I was going to add a second one just to fill in that space there. But if I move from side to side, you can see the parallax effect. So we can see that it's not actually built into the ceiling, it's actually separate, which is what we wanted. So yeah, that's there we go. One thing I've noticed is that when we escape, when we come back, we don't have focus anymore. So we don't. So it's not. Oh, okay, yeah, it's weird. It only sometimes captures the focus of the windows. I think means I need to stop everything from capturing focus by default, which we can also add in. But okay, so I have this back. Yeah, we definitely, because it's if I double click, you see it selects all the text at the top. So that's not something we want. So let's try and fix that quickly. I cannot rightly remember what it's called. Just Googling. Use the pointer events. No. I think we add that. Just going to look up the definition of pointer events, because we need to turn it back on for the canvas. Looks like auto. Great. So let's look back at our window, and oops, try clicking in and out. Okay, yep, and even when I click up here, I still can't select anything, which is great. Do still need to click back on the actual 3D window. At some point we'll make this the same width as the entire game when we don't need the debug anymore. But there we go. Now we have an aiming system. Obviously the direction was a bit off. We noticed that last week. So let's rid of that. But that is a great start for this week's progress. So we've made progress either way. Just gonna check in on streams and everything. Yep, doing good. And we have 20 minutes. Okay, great. So I'm actually going to check this code in now, because otherwise it's going to clutter up the next one. So I need all the icons. Capabilities default. Basically everything in the source Tauri folder. Utils, yep, I want that. That's goes right there. Me. Okay. Put those in, and should probably add the cargo lock as well. So this is as and mouse cursor capture. Okay, I'll be pushing all the code at the end of the stream. So that's great. Let's minimize this, and we'll look at announcement. So now we need to adjust the not the player look actually, although probably have a look at that and see what it gives us. I just wanted to check what it does. So essentially, it just changes the rotation in the X coordinate and the Y coordinate, so left and right and up and down, and traps it within a 90-degree window. Are we 90-degree window? No, it's 180 degrees because it's between plus and minus. Sorry, just got a message. Yes, I've also realized I have to pop away for just 1 second. Oh, apparently it's thunder starting outside, so that's great. Hopefully that won't get picked up on the stream. But yes, I'll be back in just a second. I'm just going to have to mute and pop away. Okay, and I'm back. Sorry about that. Just to put something on with me. So, where were we? Right, so we're looking at this, and now we need to, when we cast the firebolt, this is where we want to get the up and down positions. So I'm going to suggest actually that we just set the debugging purposes, set the Y to 0. Oh, and the velocity. Oh gosh, okay, yeah. This is... Yeah, I don't know how we arrived at these numbers. They don't look right. So the rotation Y is going to be, yeah, because it's the rotation around the Y. Okay, that does make sense. This is what makes it a 45-degree angle. That's why. Yeah, let's make that right. Yeah, so it should be a 90-degree window, I think. For the looking in the that coordinate, and then we'll change the rotation to be equal to. Yeah, I think this is where that inaccuracies coming in. Yeah, it's like doubling up. Yeah, that's okay. So okay, so that is sort of working. Obviously the direction it's facing is wrong. I'll address that in a second. But this is too narrow of a window, so I think actually we'll go back to what we were doing before. Yeah, and this, I think that's why we added those 0.5s, because it's correct around the center point, which is where the rotation will be 0, but then it drifts off a lot further as you get around. So let's try and figure out what's going on with that. Drag you. Let's just maybe we stick to not allowing rotation in the Y direction for now. So this should just let us look from left to right, which should help with debugging this one. Yeah, we're just debugging in one plane then. Okay, so let's try to figure out why those rotations are not still quite tight. But yeah, I think we probably should be able to look a bit more than that. Try going for this 180 degree movement. Okay, it didn't like that. Or didn't it like that? Oh, yeah, it didn't like frac pi. Okay, that's a real value now. So I suspect this is going to be too much. Okay, that feels the same, which means that we're probably limiting it to someone else then. See, because it's a bit annoying that we're looking ever so slightly up. I think going in the wrong direction. One. Okay, this is weird. I think this isn't rebuilding the front end properly. Now we're capturing all of the pointer events on the front end. That's, yep, that's great, we broke that. So, what we'll do is take that and then we'll create a separate CSS file, game CSS. Put it in there, so that then we only import this. Oh no, that's not going to work because it's all driven from here. Huh, that's an interesting. Okay, yeah, it's not really the right thing. Oh, I know what we can do. Yeah. Take that, get rid of this file. that back, and then we'll put it on the button. So it's the green page. Do we make a? Oh, it's called home. Okay, and it's a link button. So it's there. And set to enter events here. Enter. Let's see what that does. Okay, great. We can actually, yeah, okay. That's why, yeah, it wasn't rebuilding and repositioning for some reason. Now we're looking too far down the floor, so I think that needs to be 1.5. Okay, that's good. Yes. Okay, it's good. Still not getting the rotation. It still feels really tight. And I'm wondering if there's something else that's clamping that. Let's try expanding the field of view. Okay, yeah, that's nicer. Makes me think maybe we're doing something with the camera when we render. It's causing the look rotation. Yeah, look at X and Y. Oh yeah, it's this. Location, we're looking at self-correct get look rotation. That's not right. That's yeah, that's really not right. Okay, so that wants to be try that and get rid of the extra thing. Okay. Right. This is more like it. Okay, so because we wanted it to be 0. So let's change the look back to 0, so it's just looking straight forward. Okay, that's now bouncing between, which normally indicates that the values of the rotation aren't working. I think zeroing in on what the issue is. So the loop rotation just goes up. It's not. It's just controlled by. That's effectively sensitivity. At some point, we can make that a setting. So let's draw this out. got our location here in 3D space. And then we've got a rotation. So if we imagine we're looking down player, and our values here go from minus pi to pi. We want to pick a point that's essentially we want to create like a unity circle here. So it needs to be yeah, okay, this is, I think I'm understanding what's going on now. So if we want to do the look at, we just want to we need to pass the Z. Yeah, why? It's going to be X. So the Y we're just going to set as player lock Y for now, so it's directly in front of us. And the Z is going to be player lock Z. We can't zero cos. Is that right? Yeah, it's still bouncing between the two. So when we're looking straight forwards, the rotation is going to be 0, and we want to be looking at the points of say our player is at 0. So player lock is going to be 0, 0, 0. We want to be looking at one block in front, so that's going to be 0, 0, and 1 when theta is 0. And then when we're at pi, yeah, this explains why the look rotation code wasn't working. So then when theta is pi, this needs to be at the maximum, so that's going to be at whatever is 45 degrees from there. It should be, is that root 2? Well, let's go with the 90 degrees for now. Yeah, pi was just arbitrary to use for the limits. I don't know. Yeah, because pi would be 180. That'd be down here. Okay, so we want to take the so the rotation is going to be, yes, I think we need to limit this to pi over 2. So let's go to frac 2 pi. Hold on, see what that is. That's not half of pi. By 2, that's half of pi. So we want that, and we'll set it for the x. Great. Cool. Okay, so that should be here, and when it's at pi over 2, the lookout points should be x should be 1. Y is going to be 0, of course, and z should be 0. So that needs to be, that would be draw this out, sine and cosine. So, oh no, cosine's the inverse, isn't it? So, it's terrible drawing. No, it's not the inverse. It's not the inverse at all. Cosine starts here. and crosses at the pi over 2. So yes, there we go. That's how we do that. So Z is going to be the plus the cos, and that's going to be plus the sine. So this should allow us to look from side to side. It's still clamping. So this might be that issue again, but it's not rebuilding the front end properly. So rebuild that. Yeah, it's still clamping between those values. That's very odd indeed. Yep, it's because we're not passing Zs. Okay, nice. Right, now we're getting somewhere. So that's now going between pi over 2, and we can look from side to side, and we can see we never actually filled in that back wall. So that's the next thing. We don't want to see, don't want to be able to see the back wall really. So actually let's do 3. Can't remember if we. Okay, yeah, we can see from the look at that it's going from minus 1.57 to plus 1.57, which is great. That's the those are the clamps that we put on, and what we actually want is going to be probably pi over 4. We'll set it to a proper 90-degree angle for now. We'll just see. I suspect it's going to be pi over 3. Oh, actually, no, that's quite nice. That's 45 degrees on either side. So if we look at our diagram, it's going from here to 45 degrees, which is pi over 4, to minus pi over 4, which I like. Yeah, I think that works. It gives us a nice range of movement. I wasn't thinking that they would come that close anyway. The only thing I do notice is that it's inverted, so it's not going in the right direction. We'll deal with that. It's going to be to subtract from the rotation. There we go. Yeah, and I'll. Okay, we've obviously got everything inverted because the minus 7.9 on there. And actually, it's realized in our debug we want to add the Z as well. Okay, cool. Did not like that. Where we're going to look at from. Those are not the right values that we want. Yeah, no, because it's not the actual look at, those are the rotations, that's why. Just labeled it wrong last time, which is a good lesson in why you should label things correctly. So there we go, we have our rotations going from minus 7.9 to 7.9. Sorry, 0.79, which is good. I was going to put some cover or something on the near walls just in front, so and this enemy character guy won't be coming this close. So that's all good. They're going to be mostly further down the room, I think. And who knows, we may end up not making it a rail shooter after all. And making an FPS so that we can move forward as well. Although that would rather, I guess, defeat the original purpose of what we were going for. So maybe not. Who knows? So that's all good. And then the lock Y. Did we clamp that? Yep, we clamped that. So let's put that back to where we wanted and check the limits on that. And actually, I quite like this 90-degree movement. So let's put that back in. And the Y location is just going to be the sign, I guess, because when it's 0, we want it to be 0. So yeah, let's get rid of that. Okay, okay, we're back to looking around. Oh yeah, that's nice. Okay, that's how far down we can look, which is good. And yeah, you definitely should be able to fire at the ceiling as well. There we go. We've got a nice range of movement where we can look around. It's got this like window here. That just means that we have to put everything into here. And now we're going to sort out how it calculates the firebolts from those rotations. Now that we've sorted out those things. Oh, I'm glad to have got to the bottom of that. That was worrying me somewhat. Let's get rid of that. And we got rid of our minus 90-degree random extra hack bit in there as well. So where do we create the firebolts? We create it here. And the so we now want the location. Okay, it's spawning from the bottom, yeah, which we don't really want. So again, we'll draw this out. We'll just go for let's say that. So really, we want, this is a top-down view of the room. We've got the player location here. Really, we want the firebolt to spawn around here, just in front. So I'm actually going to make, and it depends on where they're facing. So it's actually going to be pretty much the look at position. So I think we can probably just copy and paste the look at code. So calculate the location first. And we of course don't need to call this. Let's just self.lookrot. Why won't let us do that? Oh. So nice. Okay, and location is going to be, what does this need to be? It needs to be location 3D, X, Y, Z. Excellent. Okay. Just call that location. So it's going to spawn from the point that we're looking at, and then we need to calculate the speed, which is going to be largely the same. Wow, yeah, no real hash of this. Just going to set this to set the actual rotation of it to 0, 0 for now. So go back here. Oh, look at that! It's actually going not in the right direction. That's okay. The Y isn't correct. But the X was. So yeah, the X is definitely, it's now going in the X direction. Obviously the rotation is wrong. We're going to fix that in a minute. Then yes, the Y, why is the... That's still working. Yep, that's still flying in the right direction. And all that. Yep, so even when the player location is different. So let's do it. Why? Yeah, okay, that's why I got confused. It's added all these random things in. So get rid of that. This is just confusing to have this extra stuff in. So that's negative. Okay, so the Y rotation is going from minus 0.79 to plus 0.79 looking before. So this again. So now we're looking at the player stood here. I'll draw him as a stick man because we're looking at it from the side now. And the spawn point is here. And our X rotation is going to be from minus pi over 4 to plus pi over 4. And we essentially want to, we just want to go the same trajectory. So multiplying by speeds. So when we're at 0, we want it to go 0. When we're at minus 0.4, we want it to go up. So that's why we're inverting the sign. Yeah, that should be right then. Should be minus. Oh, we've got a times 0.1 in there for some reason. Hey, there we go. That is still going a little bit above the reticle. I think that might be to do with the spawn position. So I think we want to adjust. So we do want to go back to using this. But rather than one, just going to tweak it ever so slightly till it goes still a little much. So just a little tweak in there. Okay, getting closer for sure. This is spawning a little high. Maybe that's it. It's spawning a little high. When we go to 0. So that should be us looking straight forward. Still, it's... So I think this is a problem caused by perspective, and in fact, if you look, we've been treating the player as being here, but actually the camera is here. So we're spawning the camera. I think we actually want to just knock it down. So I think actually that is just going to be 0. So I think that's correct, and actually it's the spawn point we want to. Try adjusting. Whoa. What's going on? Okay, that's like crazy sensitive. Okay, I don't know what's gone on there. Something's gone really weird. So, oh, there were two. There were two windows. That was weird. Oh, that's much better. See, it's kind of coming in. It's just not quite there. It needs to go that ever so slightly more. Let's try another half. They do seem to, they go up slightly. So I think they're spawning in the right location. They're just still maybe a little high. They're still going up ever so slightly. As close to 0 as possible. Actually, it's just that they're rising more than I feel they should be, because they're not inside the reticle at the ends, and this is absolutely a problem caused by perspective. But when we're at pretty much 0, yeah, you see it. I think the reticle is wrong. But it is the center of the reticle. Actually, is the reticle in the center? Yeah, I think this is hit the nail on the head. Is that my reticle is not in the right place? So I'm gonna just measure. I think I know exactly what the problem is. It's caused by the fact that the window isn't centered. That is exactly the problem. So everything is right with the maths, just the reticle is not in the center. So, how do we center the reticle? I think I know how to fix this. I know how to fix it quickly as a hack, which is that what we'll do is move the window to the top and then make the offset, because yeah, so the site is actually just in the middle of the window. Actually, maybe we could just make the curse. Yeah, how is the canvas where it is? That's what I don't understand. Why is the canvas in the middle? I don't think we're going to be setting those there. They're definitely the same margin. Okay, does that change? Nothing. Okay. So we know that this is 800. That's 800, and the back to our classic MS Paint. So the window is 1200 across. I actually think we can fix that. I don't. Yeah, this is what I don't understand why it's game canvas. Oh, it's just because everything is centered, is it? Text align center. Yeah, okay. I still don't understand why it's Let's have a look. Let's do inspect. Let's do Y. There's a padding of 50 px on the top. So where's that coming? Oh, it's that. Right, there we go. Okay. This is a random 50 px. I don't know why that was there. Game canvas, position relative. What's that do? Okay, that is centering it. But we actually just want I'm not a CSS expert. This is probably becoming quite obvious. But I think you can do auto. Okay, you can do that with left and right and one of those. Okay, so the thing is that we know where we want these things to be. Let's try taking the text line center out. What does that do? Yeah, okay, so we're now in the top left corner, so that's good because that gives us the oops. Okay, margin left auto and margin right auto. That's centered us now. Let's see if that will work as well. It doesn't. That is annoying. Yeah, I don't know why it works for left and right, but not that. And I know that I should be using flex really to make sure it's all correct, but I never bothered to learn how to use flex properly, and that is my mistake. So we are 900 high and 600 pixels. So we want margin top 150 pixels, and that should put us in the middle. There we go. Oh look, the reticle is in the right place now. Now I've messed up because I mean, actually, have we? That's, I don't know, that's actually pretty cool, but it's coming from slightly below. I'm really, it should come from the reticle, I think. That's so get rid of that. Hey, and now we are okay. Well, I'm glad we got to the bottom of that. And then the debug, I guess it's okay there. I'm still need it. Should be absolute to the page though. It's, I think I know what's causing that. I think it's because I put it inside the game class. Yeah. So in theory, that should have been following the game class offsets as well. But bye. Oops. Having an error in the build pipeline. Yes, it doesn't like that being outside. So can I do this with React tab? Yes, you can. Great. And now we can see the debug information is back on the top. So it's actually taking the absolute position from the top, and our reticle now points in the correct direction. The only thing we need to sort out now is the orientation of the firebolts, which I guess in theory should just be a case of passing the X and Y. So that's model rotation. anything to stop us just passing a look at as it's. Yep, compiling okay. Well, that is not quite right. It's not rotating at all. It's still just doing the same thing. I don't remember how we were using this. Rotation in the Z plane should be. We inverted them, that's why. Yes, I think it was. Look at 1 and look at 0. Oops. Okay, no, that's not right. So you can see it's rotating on the y-axis based on the height that we're looking at. So that definitely is not right. And then that should mean that it's rotating. Oh, hang on. We want to rotate on the x-axis on the firebolt itself. Which makes me think that so the z direction needs to be the y rotation. X. Okay. That and here. Send that to looking at the correct thing. I'll be back to the. Okay, no, it's not on the X plane. Rotation around the X plane would be tilting forward and backwards. Wait, it should be only the X plane, not the Z. Yeah, rotation on the Z plane is just making it spin. Doesn't make any sense. So the thing I guess we're going to do, let's try and get the rotation on the X. So that's the model rotation 1. Should be. Let's try setting it to just a hard-coded value. So. Should be just tilting forward now. It's not doing that. Rebuild just to see if that's the issue. Rotation. Yeah, I don't think anything's setting the rotation itself, but it should be. Oh, that's why it's because it's rotated halfway. Yeah, right. So that's why it's because we made the thunderbolt, the firebolt, sorry, in this plane. So it's rotating 90 degrees so that the back end comes out, the front end goes round. so that it's at least pointing in the right direction, 0, 0. So let's try setting that's 0, 0. This is just to sort of cause it. I want it to tilt forward, basically. That's the. Yes, it's not. Oh, okay. Let's. What? Why is that changing? We're literally not. We're not using the X. Oh, we are using the X. Okay. Right. So there we go. That's. And that's with a 90-degree. Oh no, that's with 180. No, it's 90 degree. Yeah, so we've got a 90 degree. It should be tilting forward. It's not tilting forward, but then it did tilt forward on the Y plane. So maybe I've got the axis wrong completely. Let's set that back to 0, 0. See what happens. So this is. Oh, we didn't. Okay, so it seems the original model then. Right, the original model is pointing right. So yeah, this diagram was correct, but everything's inverted because of the way that we've got the camera, which is why rotating to a negative moves us to the right or makes us to the right. So that, and I think this is to do with the order that we're adding these rotations in. So if I now make that pi over 2, this now points upwards, yeah, which makes sense. So if I make that just the model rotation dot 1, it's the Y rotation. Quite like how the firebolt disappears into the night sky, quite literally into the model of the night sky. Exploding over there. That's really funny. So but then they're just okay, so that is changing the, yeah, it's changing the angle of attack, but in the wrong, is that the wrong direction? Yeah, so that's negative because it should be pointing up when you're facing up. Okay, yeah, so that's, and we can see that it's going down. Yeah, so that's correct now. But when we add the 90-degree turn, I think we'll lose that. think we need to add it to both. But perhaps it's a negative. It's just not playing ball at all. I suspect it's because we need to have an actual matrix rotation instead of whatever set rotation is doing. Oh no, it's doing some sort of rotation. What function is that? That's in the render, yeah. So it's down to the shader. And that is, it's doing a proper matrix rotation. Combines them in the ZYX order. Just trying to add the X back in. I think we might just have to live without the Z and X rotations, you know. No idea why this isn't. Yeah, just rebuilding. So yeah, that Y rotation is not doing much. Okay, I am gonna slow down the speed of the, where's the speed? Like that. Okay. So slow down the speed, and then on the updates, I'm gonna just change the we don't actually record the rotation. We should record the rotation at some point. Does the model have a get rotation? Does not. Oh, rotation's public, okay. motion. Is that going to compile? It's not. Okay, so this should cause it to spin in whatever it thinks the Y direction is. No, it shouldn't. Probably should go via the delta as well. So okay, so we can see that the Y rotation is causing it to spin in that direction. So what happens when we just set X? Get rid of that spinning thing. Aha! Well, that's correct, sort of, except that that's facing towards us. Yeah, so you see that's facing towards us, and that's facing away. So that one's correct. I think I know what's wrong. Const pi minus that will invert that behavior. Okay, yeah, it's almost correct. Now we need to add that. The negative rotation back in again. It's going the wrong way because the red tip is in front. Add that. Yes. There we go. That's working. So now we will do the same debugging technique as with this to make it rotate Z rotation. Z. Just set this to oops. Okay, now we can see which way Z rotation is spinning. Yeah, rather chaotically, unfortunately, because the Y rotation causes it to offset. That's why it's like wiggling. And then maybe let's try with the X rotation, because I think we're almost there. We're almost there. unfortunately, because of that changing Y rotation, it causes it to spin. Rather than rotate forward or backwards. Well, that is disappointing. I guess one way to fix this would be to realign the model so that it's kind of facing in the right direction rather than going left to right. It's actually heading away from us to start with, so that we don't have to do that Y rotation. Curious what happens if we set the I think my solution is going to be a little bit more hacky. Going to leave all of this rather than trying to apply the two rotations one on top of the other. So get rid of the updates. Get rid of those. I'll leave those in for debugging later on. Just kind of curious what that does. Maybe let's try adding it to the it just doesn't rotate anything at all, is it? Maybe we need to do that again. Nope. That is definitely in the wrong direction. It's not. Oh. Is that tilting down? Let's negative on that. Yeah, it's just messing up the whole. Yeah, looks like we're only going to get one thing. Okay, so my hacky solution to this is to set that to 0, 0. And then just make the model smaller. So you can't really notice that. You can kind of notice. Size of the shards looks a bit ridiculous now. Maybe scale. Make it about the quarter the length. Ah, there you go. You can't really notice now. There we go. So we just hacked our way out of it. Okay, let's return the speed to its original speed. I think it was 0.1, but I actually felt that that was itself quite small. It does feel a bit ridiculous now that the shards it creates are slightly bigger than the bolt itself. So we'll go to the shards. Okay, there's try something else to 0.02. A little bit small. A little bit bigger than that. That looks nice. Okay, and I want to make them a little bit faster. Obviously, in the original Virtua Cop, they were bullets, so they went significantly faster. That's how long it takes to go down the entire room. Still a little bit slow. Let's try 0.03. I think that's good. There we go, we now are exploding. Okay, well, we now have a bullet. I think we can work with that. We can make that. We can finally shoot this guy who's been just staring at us while we've been looking all over the place today. Unfortunately, I'm not here next week. The week after, I will be here. So, yeah, I guess I'll see everyone in a couple of weeks. I will check the code in following this, so you can check it out on GitHub. Yeah, stay safe, take care of yourselves, and hopefully see you next time.